Okay, here we go with the next video. There I am. There I go. We're going to determine the concavity of this natural log function. Doesn't look like it's a complicated function, so that's good. For the concavity, we're going to have to figure out where the second derivative is positive and where it's negative. So we're going to have to find the second derivative of this function. Now remember, with natural logs, for derivatives, if the absolute value really means nothing as far as derivatives, you can ignore it. So what this really does is makes the domain of this function a lot larger. So like you could get a negative and the absolute value will change it to positive. But other than that, it's not going to change how you would approach this problem. So the first derivative, again, ignoring those absolute values, is the derivative of this is just u prime over u. So the derivative of x minus 1 is 1 over that. So that's a simple first derivative. Second derivative, you can use the quotient rule. I don't like to do that when I have a constant on top. I will use the chain rule. So I'm going to think of it like this. So f double prime would be negative 1 times x minus 1 to the negative second, or negative 1 over x minus 1 squared. So there's my second derivative, and this is what I'm going to base all of my possible points of inflection and concavity off of. So we do have a possible point of inflection where this second derivative is undefined, x equals 1. Actually, it really isn't a possible point of inflection, because if you plug 1 into the original function, it would be the natural log of 0, which is undefined. So this is not a point at all. But it could change concavity there. So now, normally when we talk about natural logs, we go from 0 to infinity because of the domain of the natural log. Here, since it's absolute value, you can go all the way to negative infinity. So I'm going to calculate the second derivative at 0 here and the second derivative at whatever here, 1,000. Really, I didn't have to do any of this. I'll explain that in a second. But if you plug 0 into the second derivative, which is right here, you will get a negative over a positive. If you plug 1,000 into the second derivative, you will get a negative over a positive. So it goes from concave up to concave up. And that's what I was looking at. When you see the second derivative, just because of the fact that it's x minus 1 quantity squared on the bottom, the second derivative is always negative. And I don't know why I put positive here. Now there's a mistake. I don't know if I said negative and wrote positive. I'll have to review it. But anyhow, when I plugged 0 in, I got a negative over a positive, which is negative. And when I plugged 1,000 in, I got a negative over a positive, which is negative. And then, as I was saying, the second derivative is always negative. It has to be. Now, it doesn't exist at 1. We already discussed that. So you would say this graph is concave down on the interval negative infinity to 1, and then again from 1 to infinity. So you don't include 1 just because it's not there. So that's that. Hope you enjoyed that one. Can't wait to see you on the next one.